All right, so do we want to start at number 1?
Sure.
Okay. What's triangle JMB congruent to?
Would be RPD.
Correct. Yeah, and I'm not sure that it really matters. Here, if I draw a picture, in other words, if I have a triangle and I call it MJB, I could just as easily call that JMB. They're the same. MJB and JMB are the same triangles. So if PRD is congruent to MJB, then it's also congruent to JMB. Now, whether you have to rename it or not, like you did, you called it RDP, I think.
RPD?
Yeah, I don't know. I think this would also be correct, just to say PRD.
Okay.
Okay? In other words, it's just the way we name triangles. We put the 3 letters in any order. That's MBJ, that's BJM, that's BMJ. There's all kinds of ways to talk about that triangle.
Yeah.
All right, number 2. Now this does kind of matter on the order. They're saying ABC is congruent to QRS. And that does mean that angle A is the same as angle Q, angle B is the same as R. In other words, I can't rotate the one on the right. So angle A and angle B, angle A is equal to what?
Q, sorry.
Q, and angle B is?
R.
Right. And only that. You can't say angle A is the same as angle R. I could describe that triangle in another way. I could call it triangle BCA or CAB. But if I'm going to talk about 2 triangles being congruent, then I got to keep the letters straight so that I know which angles are congruent with one another. All right, let's see. To prove that DEF is congruent to GHK by the side postulate, you must first show what?
I have no idea.
Well, this is a poorly worded question. First of all, their grammar doesn't make any sense. So, if I'm going to prove the triangle DEF, the one on the top, is congruent to GHK by the side postulate, that means that side has to be equal to that side has to be equal to that side, and that side has to be equal to that side.
It'd be line DE is congruent to line G.
I guess they're saying that DE is congruent to GH, and so forth and so on. In other words, the 3 different relationships. The thing is, they sure didn't leave you much space to write that.
Well, there's 2 lines right there.
well, whatever. If you're going to prove that it's congruent by the side, side, side postulate, then you have to prove congruency for all three sides. That's basically the answer. The way they've written this here is a little bit puzzling. I don't really get the way they've done it, but I don't need to. I think you understand the principle they're getting at. Okay. Now, number 4. NP is congruent, line segment NP is congruent to RP. So let's draw a little dash mark there. And OP is congruent to QP. So we'll draw a double dash lines there. Give the reason that justifies angle NPO is congruent to RPQ. In other words, this angle here why is that congruent to RPQ?
It would be vertical angles.
That's all you need. In other words, at first I thought that it was going to require you to prove that one triangle was congruent to another. And that's why those two angles would be equal. But you don't need to do all of that. In other words, it's just vertical angles. Now how about triangle NPO is congruent to triangle RPQ? Why is that true?
Because of the side angle side. Well,
No.
the
Side angle side congruency theorem. There's a few congruency theorems. There's side, side, side. There's side, angle, side. There's angle, side, angle. But side, side angle is not one of them. So really there's only like 4.
yeah.
We haven't talked about HL yet, which is for right triangles.
Yeah.
But for non-right triangles, you really have 3. You have side, 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 you have side, angle, side, and you have angle, side, angle. And angle, side, angle, actually you also have angle, angle, anything. Because if 2 angles are congruent, then the third one automatically is. So that's the same as angle, angle, angle. What, excuse me, sorry. That doesn't prove congruency. That proves similarity. So that's not one of the congruency theorems. Angle, angle, angle. But those 3, and then they give you one regarding right triangles also. All right, back to problem 4. What says that angle O is congruent to angle Q?
The congruent parts of congruent, right, no, the corresponding parts of congruent triangles are congruent. So
CPCTC, right? Corresponding parts of congruent triangles are congruent. So CPCTC. I got that right? That's what it is, CPCTC?
Yeah.
Okay. All right, number 5, which also pertains to this triangle. Can you deduce from the given information that triangle MOR is congruent to MQN? In other words, MOR is that congruent to MQN?
Yeah, because they share an angle.
So they share an angle. And they also, NQ is congruent to OR, correct? In other words, it's just not sharing an angle. That doesn't make them congruent alone. You have to use one of these three formulas here to prove it. So here's what I'm going to do, and I always kind of recommend you do this. Separate everything out. There is MOR, and if I draw this one out, there is MNQ. Well, I know angle M is equal to angle M, and OR is equal to NQY.
Because it's CPCTC?
Actually, it's the segments. In other words, OR is made up of two segments, the double hash and the single hash. And NM is made up of two segments, a single dash and a double dash. So therefore, OR is, you can't use CPCTC yet because we haven't proved these two things. They're congruent. So you can't use them out of order. But I can use the fact that that little segment's equal to that segment. Excuse me, let me point with my cursor. That segment's equal to that segment's equal to that segment. Therefore, NQ is equal to OR. Okay. Now, still haven't proved everything. In other words, all I have is one angle is equal and one side is equal. Well, what do we need to prove congruency? Let's see. Well, we know that those angles aren't part of our triangle. We know this angle here is equal to that angle there. Why? O is equal to Q.
Because of the CPCTC.
Because of this. Those two little triangles, I'm going to put a check mark in them. That triangle and that triangle, we just proved were congruent in problem 4, right?
Yeah.
Well, proving they're congruent makes that angle equal to that angle. And that O is equal to Q. Now, that is angle, side. This is angle, side. That actually is one of the postulates. It's the fourth one. I didn't list. Let's erase that one because we haven't gotten to that yet. Okay? So by angle, side, we know that that is true. Do you see why separating them out kind of helps a little bit?
Yeah.
You draw them separately because it's very hard to look at that and mentally or visually pull out the triangles they're talking about. And they can make them really complex. So whenever you have a problem where you got a lot of intersecting lines making up a lot of triangles, try to separate them out like I've drawn them, and it's easier to think about them.
Okay.
Okay. And angle, side works because if those two angles are equal, then R has to be equal to n. And now we have angle, angle, angle plus one side. That proves congruency.
Okay.
All right. Given that MO is congruent to MQ, prove that angle O is congruent to angle Q. CPCT. CPCTC. Given that, prove the other. Well, the only way we can really prove it is that they are both parts of congruent triangles. In other words, this picture that I have shown here, we just proved right there that MOR is congruent to MQN, right?
Right.
Well, that's the reason that's true. It's not so much because of that. It's not that MO is congruent to MQ, although I guess you do need to kind of know that there are the corresponding sides of those two triangles. MO is the corresponding side of MQ. And as long as that's true, then angle O has to be congruent to angle Q based on CPCT or CPCTC. Now, given that angle NPO, if we look back at the original triangle, that's that angle there. Oh, that triangle NPO, that little tiny triangle, is congruent to RPQ.
Yeah.
I'm a little confused.
Yeah, I can pull up the answer key.
Well, didn't we prove that
I
already?
think we can say yes or no. Because they're just asking,
Because
can you...
if so, what postulate or theorem can you use?
So it'd be like ASA or AAS or SA.
I'm not sure. In other words, we proved it originally by SAS. I'm a little confused by question 5. Because given that we proved that they were congruent, in other words, we proved that statement. 4B. Therefore, 5A is true and 5B is true. 5A is true because CPCTC, and 5B is true because of SAS. Like I said, I'm not real sure what they're looking for here. Given that, now I get it. Can you deduce that MOR is congruent to MQN? In other words, they're ignoring question 4, which I didn't get. If I know that MO is congruent to MQ and that angle O is congruent to angle Q, can I deduce those two triangles are congruent? Well, let me think for a moment. Let me change colors. Now I understand what they're saying. So if I know strictly that MO is congruent to MQ and that angle O is congruent to angle Q, is that enough to prove congruency? No, that's only two parts. I don't know the third part yet.
Okay.
Now, if I know that NPO is congruent to RPQ, well then, okay. I apologize. I'm right. I'm right. In other words, we're trying to prove that, which is proving that that's congruent to that, okay? And we can't do it with statement A alone.
Well, in the question itself, it says, oh, never mind.
Well, it's a strangely worded question. It really is. In other words, especially after question 4, because question 4, they just asked us to prove that. They asked us, well, no, I guess they were asking about different triangles in question 4. So question 5 really has to do with the two triangles that I've drawn separately here. And if I am given statement A, that's not enough to prove congruency. But if I've given statement A and statement B, well then I know that R is congruent to N, and it's congruent based on angle side. So
Okay.
given both of these statements, A and B, then you can deduce that triangle MOR is congruent to MQN. But you need both of them. One alone doesn't do it. I don't think so. Even knowing that NPO is congruent, that actually might do it. Yeah, that does. In other words, statement B alone. If I know that that triangle is congruent to that triangle, then I know that side's equal to that side's equal to that side, therefore that side's equal to that side. You have an angle in common, and I know that that angle is equal to that angle. So statement B alone does prove congruency. Statement A alone does not.
Okay.
I think that's what they're trying to get you to say.
But it says, if so, what postulate or theorem can you use? So for B, what postulate or theorem can you use?
Well, let's see. We proved that that is congruent to that because those two little triangles are congruent.
Yeah.
We also proved that OR is congruent to NQ because the segments are equal. In other words, NP is equal to RP and PQ equals PO because these two little triangles are congruent. Therefore, NQ equals RO. And they both share that. So we have angle, angle, side.
Okay.
So that's angle, angle, side. Okay, let me scroll down here. Let's draw us a triangle. Label it K, R, Z. Angle K equals angle Z. What kind of triangles that make that? Right off the get-go.
What?
What kind of triangle does that make that? The moment I know that angle K is congruent to angle Z.
Would it be isosceles?
Yeah, automatic. Because isosceles is two equal sides, but also the angles opposite them are equal. So I know that if these two angles are equal, then those two sides are also equal. Has to be. Okay? And now it says KR is 9x plus 2 and RZ is 3x plus 20 and KZ is 6x plus 14. How can you solve for x? It's an isosceles triangle. What does that mean?
Well, 9x plus 2 equals 3x plus 20.
That'll let you solve for x. What's the solution here? How do I solve this?
Oh, sorry. You subtract 3x from both sides, so it'd be 6x plus 2 equals 20, or 18. 6x equals 18. And then x equals 3.
Okay. Once you know x equals 3, you can answer, well, that's the answer to the problem. Notice we didn't need to know that.
Yeah.
That was immaterial. Tells you what that third side is once you solve for x, but if they're only asking for x, the only thing we needed to know is KR and RZ. Those were the two sides that were equal. All right. If the vertex angle of an isosceles triangle has measure 60, then the triangle is both what and what? In other words, here's a isosceles triangle, and by definition, those are the two angles that are equal, those are the two sides that are equal, and it's saying that's 60 degrees. That's the vertex angle. The vertex angle being the third angle. The angle that's not necessarily equal to the other two.
Okay. So wouldn't the other ones be like 62 though?
Correct. Which makes this a very special isosceles triangle. What is this called? Equilateral.
Yeah.
Mm-hmm. In fact, the two answers is equilateral and equiangular.
Okay.
Now, equilateral means both. So I'm not sure what they want for answers here. For the two different answers, you could say equilateral and equiangular, but once you know that it's equilateral, you don't need to specify that it's equiangular. That's given.
Okay.
But maybe they mean then the triangle is both isosceles and equilateral. I'm thinking that's what they probably mean. Or that's what they want in terms of answers. I can't think of what else they would want. What two things would it be? I guess equilateral and equiangular could be an answer, even though they do, if something is equilateral, then it's also always equiangular.
Okay.
Number 8. RST. U is the midpoint of RS. Then TU is what?
The median.
It's the median. Let's talk about this. if I have an angle or a triangle, and I start with any vertex, let's say I decide to bisect that angle. That's an angle bisector.
Okay.
Let's say I decide to go from a vertex and draw a perpendicular to the other side. That's a, forget the name of it. And the other one is where you start from a vertex and you go to the midpoint of the other side, the opposite side. That's a median.
Okay.
That's just a perpendicular, what is that called? Gosh, I drew a blank for a second. It's because I've always felt that the names on these things isn't important. The point is what it does. Okay, that's median. For some reason I remember that name, and I know that angle bisector is the other name. And the other one is perpendicular. I want to say perpendicular bisector, but it's not a bisector of anything. So let's go to 9. The altitude is the word I was looking for. In other words, if I have a triangle like that, and I draw from one vertex straight down so that it makes a right angle, that's the altitude. If I draw from one vertex and I go to the midpoint of the opposite line, that's the median. And if I draw from one vertex and I bisect that angle, that's angle bisector.
Yeah.
All right. Hold on a second. So we have a triangle. Let's draw it. TUX, and we have XE is the altitude. That means that's a right angle. If E does not lie on TU, what the heck do they mean here? Oh, okay, I know what they mean. In other words, the way I've drawn it, it does lie on TU, right?
Mm-hmm.
But if I were to draw an obtuse triangle like that, now if I do an altitude, it's right there. That's E. That's XE, and yet the triangle is TUX. So if that angle is obtuse, then EX, the altitude, E is not going to lie on TU. So TU is an obtuse triangle. Now, I don't quite understand again why they use the words TU is a thing of RST. Excuse me, I switched problems in the middle of the problem. It's never a good thing. Then TUX must be an obtuse triangle. That's where the obtuse goes. And notice that that's always the case with obtuse triangles in some of the vertexes. In other words, if I make a really drastic obtuse triangle like that, well, now notice that even if I drop a perpendicular from that vertex, it doesn't connect inside the triangle. And if I drop a perpendicular from that vertex, it also does not connect inside the triangle. If I extend that perpendicular, they do intersect. And in fact, if I drop an altitude from that triangle and go the other way, it also intersects. So these angle bisectors, medians, and altitudes all intersect at a single place, all three lines, always with any triangle. Your medians always intersect, your angle bisectors always intersect, and your altitudes always intersect, even though the altitudes sometimes intersect outside the triangle, like this case here, because they're through an obtuse triangle. If I draw an acute triangle like this, well, then all of the altitudes intersect inside the triangle.
Okay.
Like that. They're going to intersect right there. All right. Let's look at 10. Should be relatively straightforward. Let's draw X, Y, Z. They say XY is congruent with YZ. And the measurement of angle X is 2t plus 26. The measurement of angle Z is 5t minus 7. How do I solve for t?
Aren't they equal?
Correct.
So 2t plus 26 equals 5t minus 7.
Yeah, I'll let you solve that. I'm not worried about your algebra skills. Let's go on to number 11.
Yeah.
Am I good? Am I correct on that? You don't have any problem solving simple
No, I don't.
algebra problems like that? Okay. So let's look at 11. All right, let's see if I can draw these lines here. All right, let's see. I think this is the situation. This is X. No, that's X. That's A. That's B. And YA is congruent to YB. So I know that's congruent to that. That's congruent to that. Notice I use double hashtag marks to distinguish between the single ones. In other words, AX is not the same as AY. I just know that YA is the same as YB, and I know that AX is the same as XB. And ZA is the same as ZB. Wow.
Okay.
Where is Z? ZA, let's make ZA there. Almost has to be that picture. Now we have this. That's what the given is. And these are all in the same plane. Which I don't know that you necessarily need that, but that's what they're meaning by that. And I think I have drawn a picture that fits everything that they've said. Now we have to prove that XY is perpendicular to AB. Write the theorem that justifies this statement. Well, that's a good question. What is the answer going to be? Number 11 says, see question. I can see why. No, I can't. Why do they put that comment up here?
Just like, it's the answer. Like you put it on the line.
Oh,
like you don't.
Oh, so we put it down here instead of up there. Okay, I got you. Write the theorem that says that those are perpendicular. Okay. I think we can do that. Notice that if I can prove that AZX, triangle AZX, triangle 1, is congruent to triangle 2, then that's going to prove YX is perpendicular to AB, right?
Right.
Because it'll mean this angle is the same as that angle, and the only way they can be equal is if they're both 90, because it's a linear pair. So that's all I have to prove, is that AZX is congruent to BZX. Well, we got two sides are congruent, but the third side, that's equal to itself, right?
Yeah.
So what theorem justifies this statement? Is it SAS? Is it SSS? Is it AAS? Which one?
Would it be ASA?
Side, side, side. We don't know anything about angles here. The only thing they've told us is side lengths. Notice that this side here is always equal to itself. So that is the third side of those two triangles, 1 and 2.
Okay.
So by side, 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 triangle AZX is congruent to triangle BZX, and that makes that angle AXY, has the measurement of that angle has to equal the measurement of angle BXY. And if those two are equal, they must be both 90 degrees because they are a linear pair. So they have to be supplementary.
Okay.
Okay. Now I'm not quite sure why they give us this part of the triangle. That seems immaterial to me. In other words, I don't know why I couldn't draw my entire picture like that on triangle AZB. That's the only thing they ask questions about. I didn't need to know that YA was congruent to YB. Don't care. Didn't need it.
Okay.
Not sure why that's part of the problem, but it's okay.
Wait, so what exactly is the theorem?
I would say the side, side, side theorem of congruency.
Okay.
That proves the two smaller triangles were congruent And once you've proven they're congruent, then CPCT or CPCTC proves that those two angles are each 90 degrees. So maybe it's SSS plus linear pair being equal means both are 90 degrees. Means angle is 90 degrees. So I'm not sure exactly what they're looking for, but you can certainly prove the two triangles are congruent based on side, 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 and those two corresponding angles also are a linear pair. Therefore, they're each 90 degrees if they are equal. All right, hold on a minute. Let me raise that up a little bit. Okay. That question 11 is a weird question. I feel like I'm missing something about it, but I'm not sure what. Notice even that's got double arrows on it. That's just a line segment there. Not quite sure the significance of that. Let's not belabor the issue and go on to 12a. AB is equal to BC. Then without proving triangles congruent, you know what? Wow.
That DAB is congruent to DCB.
Based on what?
Side angle.
Let me think for a second. Because we're not supposed to do it by proving the triangles are congruent. We definitely know they're congruent by the HL, right? In other words, we have the same hypotenuse in triangle 1 as we have in triangle 2, and we have one of the sides are the same and the right triangle, so we know they're congruent. And that means that all these angles are equal to one another. But we're trying to prove it without proving congruency. And what is it that they want us to prove? Without proving congruency. Well, the only thing I can think of is to create that line, and now I know that that angle is equal to that angle. Can you see all my tiny writing there?
Yeah.
Because that's an isosceles triangle.
Hey, which is a nice? Oh, they're okay. Right.
Well, it's isosceles only because AB is equal to BC, which is the only information they give us. But we can't even define that angle. So I have a hard time believing that's the answer. Let me think for a second here. I think what they're kind of trying to get at is that angle is equal to that angle. How can we prove that without proving congruency based strictly on that's equal to that?
Maybe like they just don't want us to do the proof and just like keep the thing.
without proving the triangles are congruent, you know that angle what is equal to angle what? Well, I guess that. Angle A is equal to angle C. We don't need to prove congruency because they're both shown as 90 degrees. So that's the only answer I can think they're thinking of. Okay? Now part B, write the theorem that supports your answer. Well, we didn't need a theorem. They told us both of them were 90 degrees. But if we did, it would be the HL theory for congruency.
What does that mean?
Well, that means we have two right triangles. Two right triangles are congruent if they have the same length hypotenuse and one side is the same. Well, the hypotenuse to both of those triangles is dB, correct?
Yeah.
So dB equals dB. And now you have the hypotenuse is the same and one length, AB is equal to BC, is the same. That proves congruency. So it's the HL. There are, let's see, we got side, side, side. We got side, angle, side. We got angle, angle, side. And we got HL. I think that's the only four. Side, side, angle does not prove congruency, oddly enough. I can draw two triangles that are not congruent, but they have the same. Here, I'll show you. That angle, and that side, and that side. That's the same length as that, and that angle is the same angle. So in this picture down here, I have side, side, angle. That's not enough to prove congruency. I can draw two different triangles that have the same side, side, angle, and they're not congruent. So side, side, angle doesn't work. So I believe these four are the only four.
Okay, what's the difference between angle, angle, side, and angle, side, angle?
Well, none. Okay. That also proves congruency, angle, side, angle. But notice that whenever you have two angles, you have three angles. So these two really are angle, 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 side. Both of them. So whether I call them AAS or ASA, they're both angle, 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 side, and this one's angle, side, angle, angle. So
yeah, but I would count it off if I put the wrong one.
What's that?
I would get counted off if I put the angle, angle, side.
Yeah, I know. It's got to be the correct side. Whereas these two are not precisely identical. Let me draw a situation here. In other words, if that angle is equal to that angle, and that angle is equal to that angle, and that side is equal to that side, that's angle, side, angle. Okay?
Okay.
But there's another situation that actually is different, where you have angle, angle, side. In other words, that angle is equal to that angle. That angle is equal to this angle, and this side over here is equal. And I guess that's different because if I know these two angles are equal, then I know that angle's equal. And I could just as soon use angle, side, angle. So I'm not sure they're different. It seems to me that there is a difference between them, but I can't think of what it would be. I can't think of a situation where angle side angle is truly different than angle angle side. I don't think it really is. The more I think about it, I don't see how it could be.
But like, how would I choose between which one?
I'm not sure you need to.
But I would get counted off if I put them on one.
Okay, well, let's say you have the bottom situation where I didn't know this third angle.
Mm-hmm.
In other words, I don't know that angle's equal yet. So this is angle, angle, side, angle, angle, side, okay? So this you would put angle, angle, side. This one up here, if you only know those three pieces of information, that's angle, side, angle. But the fact of the matter is, the reason this is a little different is because this side down here can't be the same side. In other words, if I change, here, let me clarify this. If I have two triangles, I know that angle is the same as that angle. I know that angle is the same as this angle. But if I know that side is the same as that side, that's not proving congruency. You see why?
Yeah.
Because the sides that are equal are not opposite the same angles. So this picture does not prove congruency. You have to have angle, angle, side, where the side is opposite the same angle. In other words, for this to be congruent, this would have to be true. Now we have angle, angle, side. But just having three angles and one side equal doesn't make congruency. You have to have basically two angles and the side opposite one of the angles be the same. And that's why this is not called angle, 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 side. Because if it was called angle, 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 side, then that side could be any side. And it can't be. In other words, this only works if the side is opposite the angle in the same manner. In other words, this side is opposite that angle. That side is opposite that angle. And that's what has to be true. Okay, I think that's it. Are there 2 pages? There actually are 2 pages, huh?
Yeah, there are.
Well, we don't have much time. Let's have a look at the second page just so I can see what we missed. Quite a bit, but that's okay. Let's have a look and see if there's anything special here. Gee, we managed to not get to the proofs. So sorry.
Proof?
What's that? What's that?
Can you do one proof?
Unfortunately, I have a 6 o'clock.
Oh, okay.
So I don't have time. If I had time, I would do one of these proofs for you. But each proof's going to be like a 10-minute problem. So I don't even have time to get into any problem at all.
Okay.
If you're desperate to see the proofs of these, we could schedule a 30-minute session, even if it only goes, it might take 30 minutes to do all 3 of these proofs. You probably need another 30-minute session to do these 3 problems.
When? Yeah.
Well, let me show you my calendar.
Because, do you have any today?
What's that?
Do you have any today?
I could do 8:30. Is that too late?
No, that's too late. That's okay. We went through the proofs today in class.
Okay.
Yeah.
All right.
All right. Thank you.
All right, Janessa. You're welcome, and have a good rest of your day.
All right. Bye.
All right. Bye-bye.